Today's lesson is on integer exponents. Exponents indicate repeated multiplication. For example, 5 cubed means 5 times itself, 5 times itself, 5, 3 times. So we're repeating, multiplying 5 by itself 3 times. So that's repeated multiplication. Now if I took out a calculator and typed 5 times 5 times 5, I'd get 125. For this expression, 5 cubed, 5 is called the base, which is the number that is repeatedly multiplied, and 3 is called the exponent. So 5 is the base, the 3 is the exponent, and if you put the whole thing together, we can call that a power. And this, the exponent determines how many times you multiply the base. So we're going to do a couple examples here. So 4 cubed means 4 times 4 times 4. And if I multiply that out, 4 times 4 is 16, and 16 times 4 is 64. 2 to the 5th means 2 times 2 times 2 times 2 times 2, 5 whole times. See, if I multiply the first 2, I get 4. Multiply the second 2, you get 4, and then another 2. So that's 16 times 2, or 32. Or you can just get out a calculator. Negative 2/3 cubed. This looks really hard because there's a negative and there's a fraction, but it's really not that bad. Squared just means write the inside twice, so I'm taking the whole parentheses and multiplying the whole parentheses by itself. And then when I multiply fractions, you just multiply the top. Negative 2 times negative 2 is positive 4, and 3 times 3 is 9, and that's it. 6/5 cubed means 6/5 multiplied by itself 3 times. 6 times 6 times 6 is 216. 5 times 5 times 5 is 125. The next couple are a little tricky because we have negatives. Some are negatives are on the inside of the parentheses and some are outside of the parentheses. So when we have the 4 on the exponent, the 4 is being applied to only the number right before it, and the number right before it is a 2, not the negative. So in this case, it's like negative, and then you're going to do 2 to the 4 by itself. So 2 to the 4 is 2 times 2 times 2 times 2, then with like a negative out in front. So 2 times 2 times 2 times 2, that's 16 with a negative. Okay. Now that's not the same thing as negative 2 in parentheses to the 4. What is the thing right before the 4? Well, this time the thing right before the 4 is a parentheses. So what are you going to write 4 times? The parentheses, and that means everything in the parentheses comes with it. Whereas on the previous example, what was right before the 4? Only the 2, not the negative. So in this case, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. And positive 4 times positive 4 is positive 16. Notice that they're not the same. When we have a negative out in front, the answer is just going to be negative. When there's a negative inside the parentheses, it turns out sometimes it's negative and sometimes it's not negative, depending on how many. Let me demonstrate this on the next problem. Notice that negative 2 cubed is very similar to the quantity of negative 2 cubed. These next two problems are very similar, except the first one means the opposite of 2 cubed because the 3 is only being applied to the 2. So this is negative 2 times 2 times 2. So 2 times 2 times 2 is 8 with a negative on it. So the answer is just negative. Whenever you see a negative with no parentheses, your answer is just going to be negative. And a negative out with no parentheses, your answer is just going to be negative. But when there's a parentheses and you have the negative inside the parentheses, that means you have negative 2 multiplied by itself 3 times. Negative 2 times negative 2 is positive 4, but positive 4 times negative 2 is negative 8. Well, look at that. These are the same, where these are different, okay? So you can't just think that oh, if it's always this way, it's going to work. It's going to be positive or negative. You just kind of have to work it out. The only ones that are clear, or if the negative's out in front, like the yellow highlighted areas, then you can definitely just know the answer is going to be negative. If your negative is inside the parentheses, well, sometimes the answer turns out positive, and sometimes your answer turns out negative. So you can't really say that there's a rule there. The yellow ones are pretty common that you can just say the rule, whereas the blue ones with the parentheses, you can't necessarily say it's always going to work that way. So that was an introduction to exponents. We have a lot of exponent rules that we're going to be teaching you, but I will, instead of just like telling you what the rule is and having you memorize it, what I'm going to do is I'm going to give you an opportunity to think about it, and then we're going to show you what the rule is. For the next problem, we have simplify x to the cube times x to the fourth. X cubed times x to the fourth. Well, I want to think about what that actually means, and then we'll give you the rule right below it, okay? So what does x cubed mean? We'll do that one in green. X cubed means x times x times x. Okay, that's what x cubed means. Then it says we're multiplying by, and then we'll do the next one in red here, x to the fourth. Well, x times x times x times x 4 times. That's what the exponent means. Well, notice that because the green are all repeated multiplication, and then we're multiplying that by more repeated multiplication, a more simple way of writing this would just be, since all of them are the same bases, how many times are x being multiplied, being repeated? 1, 2, 3, 4, 5, 6, 7. So this is x to the 7. Well, what would have been an easier way to get from x to the 3 times x to the 4 to x to the 7? Well, it turns out the easiest way to do that is just to add the 3 plus 4. Okay, so that's what this rule is saying. If a to the r times a to the s, that gives you a to the r plus s. What happens to the a? The base a stays the same. As long as it is the same, it stays the same. Just like up here. Did the x's change? No, there was x cubed times x to the fourth. The base stayed the same. What happened to the exponents? The exponents added. So let's apply this. We have 5 to the 4 times 5 to the 6. What happens to the 5? Well, first of all, it has to be the same. Check, it is. And then it stays the same. What happens to the exponents, the 4 and the 6? Well, the rule says you can add them. 4 plus 6, and that gets you 5 to the 10. Now, 5 to the 10 is a huge number, and I'm not going to have you actually work that out. That's just really, really big. How about the next one? Is x and x the same? Yes, they are. So what does the base do? The base stays the same. What do you do with the exponents 2 and 7? Well, you just add them, and that gets you x to the 9. If you wanted to write this out, that would be 2 x's being multiplied times 7 more x's being multiplied. And you can see what's the short way of doing that? Well, adding them. No one wants to write those out, especially if there's like x to the 402 times x to the 703. Like, no one wants to write out that many x's and count them. The easy way to do it is just add. So the next one, we have 4, 4, and 4. So the bases are all 4, so the bases stay the same. And we're all being multiplied, so that means I can take the exponents and add the exponents. And 5 plus 2 is 7, and 7 plus 3 is 13. So that's 4 to the 13. Again, 4 to the 13 is huge, and I don't really want to work that out because that's going to take a really long time. Our next rule is often confused with the product property rule above. So that's why I like to do them right next to each other, just so that you don't get them confused in the future. So we have x cubed to the fourth. Now, how is this different than the last example that I just showed you? In this example, we have a parentheses, and the other one we didn't, although, so we could have put parentheses around the last example, and that really wouldn't change much. The big difference between this example that I have here and the one before it is that this example only has one base and 2 exponents, where this one had 2 bases, x, and 2 exponents. So that is very different. So we have x cubed to the 4th. So I'm going to write the 4 indicates that we're going to repeat multiply whatever's in the parentheses. So x cubed is going to be multiplied by itself. X cubed times x cubed times x cubed. Now if I go one step further, x cubed means x times x times x. So in each of the parentheses I have 3x's being multiplied. And now we have all of these things being multiplied because parentheses means multiply. How many things do I have being multiplied here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is a faster way to get from 3 and 4 to 12? Well, in this case, you're just going to multiply 3 times 4. So if you have one base and two exponents, you multiply using the power property. If you have two bases, like we did above, and two exponents, that's when you add the exponents from the product property. So our rule is if we have a to the r to the s, notice one base, two exponents, then you multiply the exponents. So here we have one base 3 and two exponents, so that's going to be 3 stays the same, and the exponents you multiply. Here I have one base x and two exponents, 7 and 2. So x to the 7th squared means x to the, multiply your exponents, 14. The next one, x is the base, and we only have two exponents here, so we multiply and get x to the 24.